Ken Isman, and I'm a professor here in the Fire Protection Engineering program. I just started here a few months ago, so I'm brand new really, and this is my first Maryland day. So, although you all are not my first group, so I feel like I've kind of been broken in at this point. Hope you're all having a good time with Maryland Day and learning and having fun. We're going to talk about sprinkler spray patterns here and the development of nozzles that help discharge water to fight a fire. But before I go any further, I want to see, is there anybody here who's ever designed a nozzle before? Anybody ever designed a nozzle? No? Is there anybody here who's ever used a garden hose? Yeah, everybody's used a garden hose, right? What happens when you're using the garden hose and you stretch the hose as far as it can go, and then you need the water to go a little bit farther, but you can't get the hose? What are you doing? That's like the universal sign everybody's been doing today. What are you doing? You put your thumb over the end, and what happens? The water goes farther because the velocity of the water is increased. Well, there you go. You are a nozzle designer. You just didn't know it. That's what you've done, is you designed a new nozzle by sticking your thumb over the end of the hose while it's discharging water. Well, that's what we're trying to do here. We're trying to increase the velocity of the water coming out of these nozzles that we use to get water towards a fire, out of things like fire sprinklers and other nozzles we use to discharge water. Only we're trying to do it in a way that's a little more scientific than just sticking our thumb over the end of the outlet. Now, before we even go much further than that, I want to ask the basic question: why are we trying to get water on a fire? Why do we use water to fight fire? Because it works. What's it doing? The water is absorbing the heat from the fire. 1 pound of water will actually absorb somewhere between 7,000 and 8,000 BTUs of energy. Water is incredibly efficient at absorbing heat, which is why it's a tremendous agent to use for firefighting. There are two other reasons we use it though, because there are other agents out there, there are other chemicals that can fight fire. But why do we use water most? It's inexpensive. And why is it inexpensive? It's abundant. It's readily available. There's lots of water around us. Unless you're in the middle of a desert somewhere where water's a little more scarce. But water is a plentifully available product. The third reason we use water is it's non-toxic. So if there are people in the same place as the fire, we don't have to worry about discharging water on them. They'll get a little wet, but they'll be okay. So those are the three reasons we use water. Now, water's been discharged out of fire sprinklers to fight fires for more than 100 years. The first fire sprinkler was actually invented in 1873, 1874, somewhere around there. So it's been around for more than 140 years, actually. They've been inventing and using fire sprinklers to fight fire. But up until now, nobody's been ever able to answer the question, how big are those water droplets coming out of those sprinklers? And how fast are they moving when they come out of the sprinkler? And we know we need them to be moving fast to fight down through the fire plume, the hot gases that are coming off the fire, and get to the base of what's burning and actually get it wet so it stops burning. But we've never been able to figure out the answer to that question. How fast are those water droplets moving and how big are they? Until this machine was invented. This was invented here at the University of Maryland. Right in this room, they invented this machine. They call it the 4S machine. It characterizes sprinkler spray patterns. And what it does is, we've got a sprinkler in there and it's discharging some water. The water goes into these collection tubes at very specific locations in the pattern, and we can gather some information about what's happening just by collecting the water at specific locations and measuring it. But even more information is collected. Normally inside this, there's a laser. And I apologize, the laser isn't here today. Someone is using the laser somewhere else. We wanted it for Maryland Day, and they said no, they needed it somewhere else. So we don't have the laser today. But there's normally a laser in here that helps give us information on what those water droplets are and how big they are and where they're moving and how fast they're moving. And this whole assembly with the sprinkler in it rotates. And we keep the laser steady, and we rotate the assembly around the laser, and it can capture the information about what the sprinkler is doing in a spray pattern, in a 360-degree pattern around, as we capture that information as it rotates. And we take all that information about the water droplets and their size and their velocity, and we put it into a computer program. And when you came in, you walk right past the monitor there. If you peek around the corner here, you'll see the program's running that's characterizing the water droplet distribution from a very specific sprinkler. I think it is actually this sprinkler that's in the machine right now. By understanding the size of the water droplets, the velocity of the water droplets, we can better design fire sprinkler systems for buildings. This spray program here is actually color-coded for us. The white droplets that you see in the screen are very big, juicy, fat water droplets. Those are the big mass water droplets that are going to fight their way through the fire plume and actually get to the base of what's burning and help put that fire out. The green little water droplets that are there are smaller water droplets, and they're important too, because the surface area of those water droplets is very large. There's lots of them with lots of surface area, and they're absorbing the heat from the fire and helping to prevent that fire from spreading to another area. The perfect fire sprinkler will have a mixture of some of these big water droplets and little water droplets. But the challenge for us in fire protection is to figure out what the right mix of those water droplets is. And for any given building and for any given space, that's going to be different. In a big, tall space, you're going to need a lot of big water droplets. In a space with only a short ceiling, you would need a lot smaller water droplets. So by understanding how fires are going to form in buildings, and then understanding how the sprinklers are going to spray water throughout that space, we can work with architects and engineers to custom design fire sprinklers for very specific purposes and very specific buildings. And you can see we're doing that. We come up with ideas on certain kind of fire sprinklers that would work well in certain spaces. We use a 3D printer to print a prototype of the sprinkler. We put it in the 4S machine. We characterize how it's going to operate, and we generate information on a program like that. And then we can use that information to decide whether this is going to be a good design to use in a specific space or not. So this becomes an incredibly important tool for the manufacturers of fire sprinklers to be able to figure out how their devices are going to perform. On the wall behind you, we set up 4 of our nozzles just to show you just something of sprinkler spray patterns. These are smaller, finer spray patterns that would be used in small spaces, low ceiling spaces, just because we didn't want to get you guys really wet with tracking out the stuff that sprays water everywhere. The one that I think is the most interesting is the one third in from the left, which has water actually spraying out in a corkscrew pattern. It's kind of an interesting little unique custom design that a specific client was interested in achieving this corkscrew kind of swirling pattern to the sprinkler spray, that particular nozzle spray. So having these tools can work with people in the industry to really custom make whatever it is that would make fire protection better for them. I should mention that we're not wasting any water today. I don't want anyone to go away thinking that we are spraying all this water around and wasting water. All this water that's being used here is going through these holes in the floor. It's collecting down into a big tank that's underneath us, all the way down, I think on the first floor or under the building. And then there's a series of pumps that pump it back upstairs for us to use here. So it's all being recycled. And in fact, fire sprinkler technology is a very eco-friendly technology. If we didn't have fire sprinklers in buildings, it would take firefighters thousands of gallons a minute to fight a fire in a building when they arrive. Whereas the sprinklers in a building only need tens of gallons of water per minute to operate. So we're saving tons of water just by putting fire sprinklers in buildings. Anybody have any questions about what we've seen or what you've seen at all in any of the demonstrations here? Anybody so psyched about fire protection they want to become a fire protection engineer? Maybe. It's a great field. I mean, I like working in a field where I know I'm providing life safety and property protection for people. It's also a great field because right now there's a huge demand for fire protection engineers. So there's right now we estimate 2 jobs available for every graduating senior. So every senior coming out in the fire protection program here at Maryland is guaranteed a job, and some employers that are looking are not even going to be able to hire because we're going to run out of graduates before they actually fill all the jobs. So if you know anybody that's thinking about college and wondering what they might want to do, I'd check out fire protection engineering. it's a field I've worked in for almost 30 years now, and I'm really happy in it. So, any other questions? Well, thanks for coming.